Hi, and welcome to another show of Kasper On BI. Today, we're going to go a little bit out of our comfort zone. We're going to go talk about modern data warehousing. What does it mean? Why is it modern? How do you get started? What do you do? Spark, Python, all of these things. And luckily for you guys, I have a guest on the channel today who knows all about it. Simon Whiteley is going to talk to us about modern data warehousing, setting it up, talking about Spark, Delta, all of these things. So I hope you'll learn. I learned a ton. So let's go over to the interview. So hi Simon, welcome to the show. I'm really excited to have you here and to talk about a very interesting topic that is on a lot of people's minds, like how to work with big data and data lakes and what is it? Lake warehouses, lake houses.
All about the data lake house these
It's
days.
all about the data lake house. Yeah, yeah. So thank you for coming, and it's great to have you. Maybe you can do a little introduction of yourself.
Yeah, sure. So thanks for having me. It's exciting.
Yeah.
And yeah, Simon Whiteley. Hello. I am a data platform MVP from the UK. So a couple of years ago now, started a company called Advancing Analytics, and we do advanced analytics consultancy, I guess. So we split the company into two sides. There's engineering, and that's kind of my side, and I do a lot of my time building lakes, helping people learn Spark, figure out how, when you move to Azure and you used to go from like a legacy SQL Server,
Uh-huh.
how you build things, how you figure out how to build a modern architecture, what the word modern means in architecture,
Exactly.
and how you kind of minimize the amount of effort to process data and do all that kind of stuff. And then on the other side, we do a lot of data science and figuring out, once you've got a lot of data in a modern architecture, how do you actually make the most of it? How do you
Yeah.
place it? And yeah, it's exciting times. There's so much going on at the moment in terms of new tech, different ways of working. People suddenly, like the whole world has suddenly gone, I should be building a data lake.
And
And
actually, it's interesting because I've known you for a lot of years. And I mean, beginning, you were doing SSIS and data warehousing on-prem. So you're kind of making this transition that a lot of people are doing right now. So that's, it's interesting. And obviously, you're a little bit further ahead than most. And that's why
I'm
that's why you're
taking the
helping
pain
people.
on behalf of other people. I'm just experiencing the hardships.
Yeah,
Uh,
yeah, yeah. That's what it's all about. Yeah.
but it is, and it's a journey a lot of people are doing right now. The BI developer, stroke ETL developer, to this data engineer term, and you hear a lot about people saying data engineer is just an ETL developer. It's the same thing,
Yeah.
and in many places it is. They're just they're still making like the same old things that they used to do, but they just kind of got a different job title. But it's different. And so might be just personal rant. But yeah, the job has changed a lot. It used to be kind of dealing with kind of on-prem single ETL tool, that
Yeah.
kind of thing.
SAP, ERP systems.
Yeah,
Well,
that,
they're still there.
building DTS jobs back in the
Yeah,
day.
DTS. Yeah.
And now it's talking about, you're talking about building reliable frameworks. You're talking about, actually, I want to do one little snippet of code that does the work of all these stuff built by config and parameters, but then you're building and maintaining code. And then you need to think about, code reusability and coding standards and error handling and logging. And there's like elements of software engineering going into it. There's elements of avoiding building a giant monolith. And that's a
Yeah.
really funny thing that I never realized before in terms of, kind of the old style pattern of having a master SSIS package that kicks off hundreds of child packages, that kicks off hundreds of grandchild packages, and you have this real hard-coded mass dependency string.
Uh-huh.
So when you change one thing, then you have to go through regression, you rebuild, you retest everything. And, in software engineering, that's called a monolith and is the devil. And you never realize it in the data world that we do all these terrible, horrible things that, if you opened it up to app dev, they'd be like, what are you doing?
Yeah, yeah.
And it's been a journey of discovery going from like a little data box to actually how do you build a reliable, stable, scalable data platform that's based on data tools that are familiar to data people,
Yeah.
write SQL in it. And
Yeah.
it's interesting times.
So maybe especially at Microsoft, we use this term modern data warehouse, right?
Yeah.
So what is it?
Yeah, so essentially there's a few different terms bandying around. So modern data warehouse is this idea of saying it's not just a warehouse, essentially.
Mm.
So you've got this idea of a warehouse, and it is intrinsically tied to a relational database. So saying, I'm going to have a relational database, likely a SQL server, and now it's going to have a data model that is governed, and it's kind of well regulated, and it's kind of just very fixed and quite formal, so that we can do regulated reporting, we can do auditing, we can make business decisions because the data is trustworthy. That's
Yeah.
this big thing. But because of all that, because of how managed it has to be and how disciplined it has to be, it's quite slow to change. If someone says, we've got a brand new data set, can you onboard it and start working with it? The answer is generally, we'll see how much capacity our server's got. We'll see what our next release window is. We'll see when we go back and test our monolith of an SSIS mess when we can next do it. And that's too slow. And so people run off and they start doing their own thing. You get dark data and siloed point solutions, all that kind of stuff. And then data lakes cracked along, right? So people started going, the big data world's been building distributed, very agile, very flexible architectures for a long time. But that's really hard. It's really hard to build like your own managed clustered distributed lake layer and some distributed compute on top of it. But in recent times, that hardship, that kind of technical barrier to getting started with big data tech has kind of gone away. You can spin up a blob storage in Azure is technically backed by HDFS's Hadoop distributed file system. It's a lake. And then you've got ADLS Gen 2, which gives you all the folder structures and the management. It is super easy to build a lake these days. And then a lot of people got really excited and built them badly, and Lake's got a terrible reputation for just being a swamp of data.
Yeah, of course.
But that's not the Lake's fault.
But so what are some of the use cases really that you would say are there any use cases, or should you just put all the data you have in your organization, just push it in there as long as you have a way to get it out?
Yeah, well that's it. So Lakes is super easy to get data in, and then you have to kind of manage it and model it and do things. But people have been able to do things they've never been able to do before. Like people used to say, oh, I can only look at like my past 6 months worth of data at once because I can't get more than that into my model at once. I can only do aggregations over a set amount. We can't deal with data from this source because it's some mad JSON nested thing, and I can't deal with that.
Yeah.
So the flexibility to work with just a ton of different types of data, sources of data, things, that's what the lake enables. And that the modern data warehouse is not saying it's a lake, not a warehouse. It's saying I need to build an architecture that's both. We want to have something coming into a lake layer that's really quick and flexible. And if someone says there's a new opportunity, we need to take advantage of it, you go, sure, land data immediately and start getting value out of that data. And then shape it and put it into some kind of more governed, more structured place. So it's enabling you to have both sides of the coin.
Yeah.
There's the whole world of data science. If you're building complicated predictive models, or you're doing like sort of a deep neural net, and you need to kind of really delve into the data and find patterns that aren't really discoverable to the human eye. You just need to go find something in there.
Yeah.
Relational databases don't really lend themselves to that. Normally, by getting data into that structure, you've cleaned it too much. You've removed some things that could be predictive signals. So it's kind of like it's saying both have value, and we want to have both sides of that coin.
Yeah. And so the way to think about it is, and I mean, there are multiple layers, right? There's the data lake where you just push all the files in, and then on top of that, you have a modern data warehouse. I'm not sure why it's called modern, by the way, but
it was modern a few years ago.
But so what's the difference between a modern data warehouse and a regular data warehouse? I think you're doing the same thing, right? You're structuring, making dimensions and facts, and structuring it so you can get value out of it with your tools that are on top of it.
So I'd say, the warehouse part is just part. So the modern data warehouse as a term, it refers to the architectural solution, which is both the lake, some kind of distributed processing, and a warehouse layer. So the warehouse layer is still doing its same job. That's still providing a structured, governed reporting layer that's easy to consume by business users, that's using terms that they understand. It's all that kind of making data accessible and consumable by the business. Yeah. That warehouse part is still the same. It's just the modern data warehouse encapsulates the earlier bit with the lake and the expansions and all of that.
Okay. So what does it generally look like? What's like the architecture? What type of products are there? I mean, I know there's tons and tons of products out there. So what do you generally use?
So we have a reference architecture. So we generally use, so we're a Microsoft shop, so everything is in Azure. So we've got a data lake that's ADLS Gen 2. The reason being is that means you can create a folder and you can apply security to that folder. So that means you can say, this team's allowed to read that data, this team's allowed to write that data. Not everyone's allowed read and write access to your lake, because that's just chaos and carnage.
Yeah.
So ADLS Gen 2 is awesome for basically building a secure lake.
And is that the main difference between Gen 1 and Gen 2, or more?
So Gen 1 is a proprietary hardware. So there's loads of really cool things inside Gen 1, but it wasn't based on blob storage. So it's not in every single data center. You can't get it in UK South, for example. And a load of people are like, especially these days in England, we need to have our data in the UK. And so that just meant you couldn't use ADLS Gen 1. So because it was kind of this kind of real specialized hardware just for building out a lake. Now, Gen 2 is essentially, it's blob storage. It's blob storage with an additional API layer that enables the folder structure, the hierarchy. So it just means it's more accessible. And blob storage is fairly mature. So there's a load of extra tools and resources and ways of working on it. So it kind of just made it a little bit more accessible, a bit more standardized, a bit more mature.
Okay. So that's where you store it, ADLS Gen 2. Yeah.
So your storage layer is this Gen 2 lake. Some kind of processing. Something needs to be able to pick data up at scale across distribution, right? So you've got to put data in a lake, which means it's taken data and it's spread it out across lots of different parallel bit disks. So you need something that can very quickly just scale out and read across lots of bits in parallel. And that these days, people are looking at Spark. So Spark's been around for an age as a big data processing tool. It's just turned 10. And in terms of big data lands, a decade is a long time for a big data tool to be around.
Oh, yeah.
And Spark, again, used to be hard. These days, we use Azure Databricks a lot. So Databricks is a third-party company that have kind of made their product available inside Azure. And it's rather than having to go through a whole lot of work and get some real hardcore tech specialists to build a Spark cluster, you can go, like a new cluster, I'd like it to be 4 nodes, go. And then suddenly you get a notebook and you can start writing Python, Scala, R, you can write SQL. And the ability to write SQL, like standard SQL, create table as, select star from, and it actually goes and queries this lake layer. Again, it's about accessibility. It means it's really easy
especially for us data people who know SQL inside out. Because I know, interestingly enough, you can also even write C#, right?
You can. So you can't in Databricks currently. But in the Synapse Spark tools, which are currently in preview, they've got C# in there. There's just loads and loads of different language choices. And that's because Spark's quite smart. You can write any of these languages and it'll turn it into the same thing under the hood. So a bit like how SQL Server has its query, estimation plan. It kind of does the same thing, taking each of these different languages and going, well, they're asking for the same thing. Let's do that under the hood. So it doesn't matter what language you choose, which is so flexible. But we use that for query processing. That's essentially our ETL engine. And it's code, it's scripty. But the point being, you can write very generic transformations. You can say, I would like to read a data set, apply this structure, chuck out rows that don't match, and then add some lineage columns and write it to there. And that is generic, not tied to any data set.
So the transformations, like going from like raw or staging, if you will, traditional data warehousing, like staging area to like you use like Spark, but you use Python, or is that?
So we use mostly Python. So it's a flavor of Python that is Spark friendly called PySpark, but it is just Python with a few commands. And SQL. So if we're saying kind of here's a generic set of transformations to apply to everything, that's just actually a fairly small amount of Python. And then you can just, that's the equivalent of what used to be like 100, 200 different SSIS packages, each kind of tweak saying this is for that data set, this is for that data set, this is for that data set.
So you parameterize it.
Turning the ground. Yeah, you can just build one thing, throw some metadata at it and go, now use that metadata, now use that metadata. And so it's very, very reusable.
Sounds like BIML.
Well, so BIML is great because it's code generation. But afterwards, after you turn the crank and you create all those things, you've still got 100 packages to maintain. You see your code footprint is still huge. Whereas this is, it's dynamic code, not code generation. So you're still only managing just like a tiny amount. So it's like these days as a ETL developer, as an engineer, I'm looking after more complex code, but actually not that much of it. We're used to be looking after real simple kind of GUI kind of code, but just huge swathes of it. It's changed, but that's our engine, right? So you've got the lake layer, you've got Spark as our get the data ready layer, and then it's figuring out a serving layer.
Mm,
And
yeah,
that's the thing that's kind of under fire at the moment. Certainly from Databricks, I've been pushing hard
of
this lake
course.
thing.
Yeah.
And that's saying, well, actually, if the Spark layer is getting better and better and better, and it can now, the SQL layer is getting richer, the interaction getting richer, the ability to do like sort of charting and visualization getting richer, and you have auditing and governance and rollbacks and transactional histories and all that kind of stuff. Do you need to then put it into a relational database?
Mm,
And it's funny because that's just where everyone's going, right? Because a lot of the relational databases, a lot of the kind of SQL Server, big data clusters, is essentially taking the relational engine and building back the lake area and saying, well, you don't need a separate lake because it's built into my engine now.
yeah,
And
yeah.
so everything's converging on this. There'll be one tool that works a bit like a lake, a bit like a database, and the whole Synapse thing is super exciting because that is, again, one platform. So
Yeah.
yeah, it's one platform that's made of lots of different tools, but it's tied together in a way that you can actually use it. And the things like the SQL on demand is massive because that's being able to use full-fledged T-SQL using Management Studio, using Azure Data Studio, and
Power
you write
BI.
just a SQL statement, but it queries a lake.
Yeah.
And suddenly kind of essentially that kind of big line that used to be lake warehouse is just blurring.
Yeah.
It's kind of turning into this. It is just one homogeneous system with different approaches. You guys access it via fully fledged SQL. You guys access it using Spark SQL. You guys write Python or R or Scala or Java or .NET, and it's just this one platform. But yeah, it's insanely powerful. There's so
Mm,
much stuff you can do in it, but there is complexity with that, right?
yeah.
And it is kind of it is getting that next level of you have to learn a lot of new stuff, learning how Spark works, learning how. I mean, so in Synapse, it's all about distribution.
Mm,
So you got the SQL data warehouse bit, or dedicated SQL pools, as it's now known. That's all about parallelism, but it's
yeah.
about how many kind of these big chunky compute nodes am I querying my data sets with. Spark. It's all about parallelism. It's how many worker nodes. And so that's the big shift that's gone from being the kind of on-prem SMP, the symmetric multiprocessing as it's known,
Yeah.
basically a single box with the SQL Server on it, to actually using the cloud. So you don't even really see the servers. You just have a little scale going on. There's this many boxes. I'm 10 boxes. I've got a really massive, I need to reprocess the history of everything I've ever done. Just throw 200 boxes at it, but for 10 minutes.
Yeah.
And
Yeah.
that's just something you can do now without having to go through massive provisioning, thought exercises, spend 2 months planning what's the biggest load. It's saying, oh, something we never expected. Turn the
Yeah.
scale up for 10 minutes. That's the kind of flexibility and the ways of working we've got now, which is cool.
Yeah. And so what about like, because it's all nice, but the problem is, of course, the lake, like the data changes. So how do you handle, like, that's a massive problem too, right? Like at one
Yeah.
point when you get history to change, like you have to have two different types of processing or something.
So it used to be hard, and that's one of the things where I'm. It's like looking at kids these days. Oh, they got it so easy, because it used to be like if you were trying to do things like a slowly changing dimension, right?
Mm,
Um, Most of the time we land data as Parquet, or kind of Parquet is the underlying file format in a lake because it's column store compression. It's like
yeah.
SQL Server column store, or even like Vertipack style kind of tabular engine. It's all
Yeah.
using column store. Parquet is just a flat file that's
Yeah.
stored using that kind of column store compression.
Yeah.
But that's immutable. It's like a zip file that's like compressed. So you
Yeah.
can't just update it. You can't say SQL Server update Parquet where blah blah blah. So essentially you have to pick up that whole file, make a change, and then write a new version of that file. And so
Mm,
we have to write all these complicated things to say, well, pull that up, make the change, put the changes over there, put the history over there. And we have these big, long, I mean, still generic and metadata-driven scripts, but big and long and complicated.
yeah.
Recently, in the past year, there's a thing called Delta. So Databricks came up with a file format and they made it open source. And that is essentially transaction logs and auditability and ACID transactions and all of that kind of stuff for
Mm.
Parquet.
But
So,
I mean, even the schema change, you're still in trouble, right?
well, it can schema drift. So
Yeah.
you can say,
Mm,
actually, I want to merge a schema in. And yeah, it's not magic. If the schema completely changed, it's going to break and you're going to have to figure it out.
yeah.
But you're
Exactly.
doing like, the normal things that SQL Server can do. You can say, just add a column. That's fine. You can append a column to the end of a data set and it's not
Yeah.
going to break the world. You can do things like that now in a lake data set. You can change data types to make them bigger. So it used to be an int, it's now a big int. That's okay.
Mm,
So it's getting more flexible to allow that kind of stuff within this transaction log, so it's not going to break the world.
yeah.
Otherwise, yeah, you have to have patterns. You have to have like a version number of the entity inside your folder structure. And if everything breaks, you start writing data to the new folder structure and then merge your data over. And that's, yeah, it's just patterns and processes that you need to get in place if you're managing a big lake, if you're managing a very kind of business critical lake. There's a lot of these patterns that are fairly well established now.
Yeah.
But yeah, it's painful.
And I mean, as we're talking about file structures and schemas, what about CDS/CDM? I know we at Microsoft we're pushing it,
Yeah.
and we're trying to make sure that we have one schema that covers like all our products. But have you been playing with it? Have you?
Yeah, so we've not done that much with it, honestly.
Yeah, I mean, it's also still in the work, so.
Yeah. And it's something that's got so much promise and potential.
Yeah.
Because essentially there's a gulf. There's like the data platform Azure people on one side, and there's the power platform people on the other side.
Yeah.
So all the things of, kind of Power Automate, not Flow, yeah, and Power Apps, Power BI, and all that kind of stuff is all kind of almost seen as one side, with Power BI being this conduit that can come in and query the data platform.
Yeah.
But it's always been a little bit awkward with some of the other bits. And then obviously on the other side, we've got Data Factory, and we've got kind of warehouse, we've got Synapse, we've got Databricks, we've got all these things. And it's always been the two don't really talk that nicely to each other.
Yeah.
And so this whole idea of being able to say, well, I've got actually essentially a common data interchange format that lives in a lake, and actually all the data platform stuff can talk to it, and all the Power Platform stuff can talk to it. So if we're passing data between, we can just keep it in that format. Is fantastic.
Yeah.
And I played around with bits of it, so taking Databricks in a lake and writing data out the CDM, taking Synapse and writing data around, being able to pull it apart either way. Actually, it still works. The problem is currently for us is that Delta format on the data platform side, because that gives us maturity in a lake. It gives us auditing. It gives us the ability to roll back and do temporal queries and all this kind of stuff. And currently in the CDM format, you can be CSV or Parquet, which means we can take our nice, well-managed, well-governed data and put it in a slightly less managed format, so that it's on, which is still better than putting it into like a CSV or a text file and dumping it in blob storage. But it's kind of, I would love to see if that CDM format is just something that natively worked across the whole lake. So actually, it's just saying everything has this manifest file in the structure, that everything can come and query it, and it's just that's how we govern and structure lakes.
Yeah.
I'd be surprised if Microsoft managed to convince the open source community that that's how they should structure the lakes they've been using for years. But if you do, fantastic.
Yeah.
But yeah, it's one of those things that it's not quite there yet. Not everything can query the CDM and work with it. I think it's still in preview for Data Factory in terms of doing those inline queries and using it as a data source for copying data. It's growing and it's nearly there. As you said, it's kind of, it's a maturity thing.
Yeah.
But it's one of those things that if it gets to that point, if it gets the maturity of the allowing Delta and the other file formats of being able to be talked to by Databricks and Data Factory and all these kind of things, then suddenly it's going to make Power Platform and Data Platform a lot closer together.
Yeah, I mean, the customers that I talk to are very excited about it, but yeah, it's more a little bit further out still.
Yeah.
All right, so maybe another interesting loaded question I mean, I'm not so sure if it's still really a case, but like, do I still need data warehouse?
Yes, absolutely. 100% you still need a warehouse. Now, do you need a warehouse that is in its own special relational database is a question.
Yeah.
And it kind of comes down to if you need security maturity features. So kind of the lakehouse stuff in terms of using Databricks, it's getting far better for that structure, the being able to have a governed thing, being able to have auditing. But it can't do things like dynamic data masking. It can't do row-level security. It can't do some of the more kind of much more mature embedded SQL Server kind of stuff.
Yeah.
So if you just need it as a querying layer and you don't want to pay for two different types of storage for your data, I wouldn't bother these days. A lot of clients don't bother putting the relational engine in because they get the analytics that they need straight from the lake. But if you're dealing with a very big, very mature, and very kind of highly featured, essentially kind of enterprise data warehouse type thing, then yeah, you need a separate thing that has all the data you need.
So I think one of the biggest benefits I think for data warehouse is like also really the schema that is applied. So how would that work when you don't use a relational database? Like, do you just create kind of like views on the data lake?
So one big misnomer that lakes don't have structure. because again, Parquet as a file format has structure inside the Parquet file. Each Parquet file says, this is my columns, this is my structure, this is how I work. So as long as you're storing your data in a structured file format that has inherent structure, then they're just as managed as a formal database table. And yeah, so we normally have, I think you mentioned, kind of that raw layer. You have different layers to the lake. So we'd have like that raw, I've just received data, I don't know what's in there. I've cleaned it up. So it's still in its original structure, but I've, dealt with data problems. I've chucked out dodgy rows. I've made sure it's in the right shape I'm expecting. And then we normally have some kind of enriched, curated, prepared layer that could be facts and dimensions. You could have.
That means you're moving data anyway, right?
Yeah.
Even within the lake. So why not just move it to a relational database that has all the benefits that you talked about before?
So you can do, and that's a choice. And sometimes it's cost. So the cost of lake storage is deliberately cheap storage because you're doing things in parallel. So like the cost of keeping data in a lake, I think, is 20%, it's either 20 or 25% of the cost of putting it in a premium full relational database. And integration. So I was doing the data sciencey bit, being able to pull it into scalable notebooks and do the other stuff. But then more and more, some of the relational engines are getting better at having things like the predict function and having machine learning baked into it. As I said, it's kind of, they're both heading in that same direction.
In the middle. It's going to be like this big clash at one point.
Not a clash, it's a coming together of thoughts. The harmonization of approaches.
But then it's going to be harder to pick, of course.
Yeah.
So let's talk about the other elephant in the room. Querying, like Power BI on top of whatever modern data warehouse. And obviously, all the customers I talk to, the only thing you want is, let's do direct query because we don't want to move data around. But then they get into performance problems most of the time. So what are your thoughts?
Yeah, so it's for a long case. Whenever you're dealing with a distributed parallel system, it's not about concurrency. So from the early days of Azure SQL Data Warehouse, everyone's like, "This is my data warehouse now. I'm going to put all my data in there, and I'm going to put Power BI on top of it." And it is awful. I've become known. I keep calling things the devil. Direct query over a parallel system's the devil normally. Mainly because things like, especially so Power BI, the way it does if you're using direct query and you've got kind of a report that's got 10, 15, 20 different KPIs, charts, elements in there, it's going to run a query for each of them.
And meaning that's only 20. I've seen hundreds.
Well, exactly, right? So just my limited Power BI things, and I've seen some horrible things. And so the early days of SQL Data Warehouse, and the highest concurrency you could get is 32 concurrent queries. And then suddenly you've got two people running a Power BI report, and it's maxed. This big, chunky parallel server is maxed. I mean, obviously the whole point is those 32 queries. It serves a lot faster because you're doing things in parallel and it can scale.
Yeah.
But you never really wanted to expose that kind of thing. And it's true these days. So with the version of the data warehouse that's in Synapse dedicated pools, or with Databricks, or with any of these big, chunky, scalable parallel systems, you don't want to throw thousands and thousands of concurrent queries on there. They're not highly concurrent serving engines.
Yeah.
But still, you still have cases where you can't get all that data into a Power BI model, or you don't necessarily want to pay for that amount to get it into a Power BI model because it's an expensive serving format, right? Well, it's not expensive, but you know what I mean.
Yeah. You have to move all the data and process it, and
exactly. So these days, it's trying to find that split, right? It's trying to say, so how much of that do I do in Power BI as this high-level model, and how much do I do as direct query? Because the answer, it's not everything. It's not everything is direct query, but the same as not everything can fit inside a Power BI model. And so we've got the recent kind of things that we put in. So things like aggregations, it's great. So query this fact table, and if it's at this level of granularity, just go from your memory, just work on that. As soon as someone tries to drill down, and then you're hoping if of your 100 concurrent users, it's only a couple. It's only one or two that drill down. And so those ones get served by the big, chunky parallel engine. And that's that nice balance.
Yeah.
And then on the other side of things, your composite models. So if you're talking about a kind of dimensional model, your fact table has an aggregation layer, and then everything else is direct query. Your dimensions are all just in cache in the import mode.
Yep.
And then you've got that nice split. You're controlling like a little gateway saying this amount of concurrency, serve it from the highly concurrent model. The things that need it, then do direct query. But that requires some thought and design. That requires building a model. And it's kind of like, the whole, open the stable doors and everyone can do self-service, go build your own data model, it's unlikely that everyone with that access is going to go, I'm going to build a highly concurrent model and serve it that way. So it does, if you're dealing with that kind of thing, it lends itself to having centralized, or at least a center of excellence, governed data model that allows for that kind of stuff.
Yeah.
But limiting how much kind of other people go with it. But even just that Power BI integration got a lot better these days. You know, it used to be, certainly Databricks used to be a little bit clunky. You have to go and get out your kind of build out a certain URL, generate a token, do all that kind of stuff. And it's literally last week, I think it was, or 2 weeks ago. There's the Active Directory pass-through is enabled. So you can just point it at your cluster, it'll authenticate as you, so much easier. So the story's getting better and nicer, but it's still, don't just turn direct query on and let users go nuts.
Oh yeah, we do see it a lot, but yeah, especially aggregations and all of these things are definitely the way forward to unlocking all of this to more user organization, especially when you're talking about like enterprise models.
Yeah, and the sign-up stuff that's been announced recently is really cool. It's going to start building materialized views and just watch how much direct queried. Oh, guide, they just queried a massive table. You know what? Let's just intelligently build an aggregation view still in the sign-up side to serve that more reliably. And that's super exciting.
And you know what's pretty cool? Like the sort of part about it that I like is the teams are working together, the Synapse and the Power BI teams. But like if it sees the query and you don't have to change the model. You don't have to do anything. You just monitor the Synapse. You see the SQL queries. You build a materialized view, and automatically it starts to pull data from the materialized view instead of the raw data. I mean, that's pretty cool.
I mean, it terrifies me of how much of that is just going to happen automatically, and I'm going to have no idea what's being built in there. But that's, my own control freak paranoia. So.
But you can probably say what you want and what you don't want. Well, we'll see about that. So yeah, so definitely and also you can have this multi-layer approach, right? We talked about this before. You can even have like 3 layers, like FruityPack, just the aggregated data, like 80% of the data is coming from there, 10% data is coming from a governed data warehouse in Synapse, and then maybe 5%, 2% is coming from directly from a Spark.
Yeah, and that's great, right? That's kind of just being able to properly structure and hierarchy levels of concurrency versus levels of depth and scalability. Yeah, it's exciting. It's cool.
Yeah, definitely.
This is a whole world that I've been away from for a while. I used to be very SQL Server, very plumbed into how that stuff's going. Went off into the big data world, building lots of lakes and lots of things, and that there's always been this big gulf going. Oh, and then we'll need to just export all the data into a certain way to get it into there. So this level of integration and being able to build data models that is this full, all the way through transparency and kind of interoperability, which is awesome.
Yeah. So maybe another interesting question. So let's say I'm a company and I have data and I have on-premise SQL Server, Oracle, SAP, but I want to start to go into this way and I want to get started. What would you tell them?
I mean, so it's, there's a lot. So there's how do you go as a person, as an individual, as an ETL developer, and how do you go as a company?
I think both answers will be interesting. Yeah.
As a person, it's probably an easier journey to make, right? It's just learning a few things. Definitely learning Python seems to be the way forward. The number of the convergence of different data tools on Python is kind of huge at the moment. So data science is getting more and more de facto. Python, R is getting a little less popular that we've seen in terms of data science. Don't want to offend all of academia, but it is the case. A lot of the new libraries that are coming out are Python based. Data processing, we're doing a lot of Spark, we're doing a lot of that big engine. We're using PySpark for a lot of that. I think now Databricks was saying, they released the other day, I think 80% of their cluster usage is now done in Python, which is crazy because it used to be just Scala, and it's just exploded in terms of that. So if you want to get into the modern kind of data warehousing side of things, certainly learning Python is definitely a way forward. And there's just a ton of resources out there. Python's been around for years. Everyone loves Python. So spin up an Azure notebook because they're kind of free and you can have a play around. You've got Databricks Community Edition is free. It's like a single node Spark cluster. And find just some kind of little program, a little objective, a little goal to try and get working in Spark and try and get this stuff working. And that's kind of just a teach yourself. Learn Python, you can start getting stuff. And then there's an Azure free trial, like 150 quid for a month. And that's like try and build some of these, try and experiment, because a lot of them, there's so much guide out there. So as a person, you can self-serve and learn and do that stuff. As a company, that's harder.
Yeah.
There's loads of kind of like sample applications, sample things. And the modern data warehouse approach, it's quite hard to get started. You need to build a lot of things.
So maybe we start with a question for our organization. Why would you want to go? Like you can be like, because it's modern and it's the new hype, but like why as an organization would you want to start looking into putting your data in a data lake?
So for me, it's about speed. And it's really funny because all the marketing coming from like the big vendors are all like, access, the size of data. If you've got petabytes of data and you can't query it, this is what you need a lake for. I actually disagree. For me, it's about being able to turn things around faster, being able to respond quicker. If you want to be able to say, look, just throw data into a lake in a sandboxed area where it's not away from the governed data, it's not kind of just adding tables to a warehouse because that's madness, but being able to just really quickly onboard some data and get someone querying it and actually asking it questions.
Yeah.
And then you go, oh, there's value in there. Actually, let's make that part of our formal warehouse. Being able to just really quickly be able to understand and act on data is massive. So kind of it's agility, it's flexibility, it's being able to take advantage of opportunities you've not been able to take advantage of before. But it does come with, if you've built a framework, if you've built some processing scripts before, you can reuse it. Suddenly then there's the agility. If you're starting from scratch, there is a bit of a barrier. There's a bit of tech to learn. There's some capabilities to grow. There's building some kind of frameworky things. Spend most of our time helping people take that first step of going, where do I even start?
Yeah.
And if you build a lake and you don't have, these are my zones, this is my folder structure, this is how I'm going to apply security in there to stop people reading and writing and managing it, then it just goes chaos. So it's not a push a button, build a lake, start dumping data in it. It does need that little bit of upfront thinking, design, get a plan in place. And that doesn't, I'm talking about a week or two of just upfront thinking and planning and getting stuff in a row. And then suddenly you can unlock all this value. But it is a leap and it is different. And it's a different way of thinking. It's like a paradigm shift approach for doing this stuff.
Yeah,
but
you need to get your developers to, like, if it comes from the top, it's usually tougher because now you need to stop doing what you've been doing for I don't know how many years and go learn Python.
Exactly. But I guess the good thing with Azure and the cloud and all that kind of stuff, it's never a fixed investment. So you can say, you know what, let's spin up a lake, let's throw some stuff in, let's see if we can get value out. And if we can't, switch it off and stop paying for it. You can fail fast, agile tenants, right? You can do a quick test something, see if there's value. If there's not, stop it and do something else. And at least it lends itself very, very quickly to that kind of thing. There isn't this massive upfront investment. There's a bit of thinking when you want to do it properly, but you can just create a lake, upload some data, give it a go.
Yeah, and then of course you on top of that you have all the mining, right? The be able to actually mine all the data that you have and maybe correlate things that you never have been able to correlate. But so what do you need to do that? Because that feels to me like it's a very different ballgame.
Not really. So I did a project of basically just document classification, right? If you've got something like your SharePoint with all of your documents and just millions of Word documents, and you just shred that and load it as pure text into a lake, that's fairly straightforward. You can actually do that fairly easily. You've got various connectors to go and get data and just land it as text. But then document classifications come a long way. So the fact that you're in Azure means you've got all of the Azure Cognitive Services. You've got a thing called Azure Cognitive Search, which allows you to run, so cognitive services are essentially pre-baked, very generic machine learning models. So it's no one needs to build the exact same model the same time every time. Like detecting language, you probably don't need to build your own language detection because that's a solved problem. Doing things like detecting sentiment, sure, there might be nuance, but you can do a really generic one, and only when you get down into the depths of it, you might want to build your own.
No, but I think more, it's maybe not the technical level, but like, how did you come up with the idea that you have to do that? Like, do the document classification? I think it's not just the technical, but you have to think about the mind switch of like, okay, so we have all this data. What are we going to do with it? And I don't know if you have any experience. I'm just wondering because I'm learning and because I'm usually in the other side of the world. But like, How do you come up with these ideas, or is that the job of the data scientist to go around and see, okay, what's the data that is available and what can we do with it, play with it?
So that it is a bit of a hard one, and I guess so. I'm kind of cheating because I spend most of my time either speaking to Microsoft about what's coming or speaking to customers about what they want and trying to marry the two up. So there's a lot of just kind of keeping track in terms of what's going on. That document classification problem, the fact that you can now do it as a off the shelf, get cognitive search and plug these things in, and it'll do term extraction and categorization, all that kind of stuff for you. Most data scientists wouldn't go for that. As a data scientist, you go, I have a problem. What approach do I want to apply? What algorithms do I want to apply? And you start scripting. You start hammering out some code. You don't go, is there an off the shelf? And so there is that kind of this, essentially, for it to work in the most efficient way, you kind of do need that kind of Azure architect, solution architect, data architect kind of role, who's kind of doing that marrying and going, what problems are you trying to fix? All right, cool. Don't know. You're in the right tool sets. Have you got what you need? Yeah, you're enabled to go and experiment and figure it out. Or have you considered these things that are made for that? It might not be the perfect thing, but it's worth evaluating. But that getting that knowledge of the landscape, especially how big the Azure landscape is and how quickly it changes, it is hard to keep up. There's a lot going on.
Even just Power BI is hard to keep up for me. I'm on the team. Yeah.
So yeah, there isn't an answer off the shelf, honestly. The Microsoft Docs are fantastic. It's crazy how much documentation there is out there. But in order to say, I've got this problem, what are my available approaches? It tends to be a bit of figuring out, it tends to be a bit of research, it tends to be a bit of asking a consultant. There's a lot to it in terms of figuring out where that is, and it's a different answer for every different problem.
Pretty excited about where the whole Synapse is going to, obviously, because we work a lot with that team and you see some of the things that are coming. That's pretty exciting to me. How do you look at that?
How do you look at what's coming up?
Yeah, I know all the the Synapse integration and all of these things.
Yeah, so the guys have been putting out kind of lots of demos things. I've been doing lots of videos, so obviously check out the Advancing Analytics YouTube channel for lots of.
Yeah, I actually saw your session on the shootout, so I'll put a link down below.
Awesome, thank you. And yeah, kind of it's essentially there's lots of people getting very excited, lots of people talking about it right now, and it's kind of keeping tracks on that. And until it leads up to GA, it's going to go live at some point. And then I think we'll see a lot more. So there's like lots of bits kind of just demonstrating, talking about it, what it could be, what it might be. And then as soon as we hit that, this is now a live in production product, I reckon there's going to be a lot more out there in terms of this is the next roadmap, this is where we're going, this is kind of the plan going forwards. But yeah, it's exciting stuff.
Yeah, and of course I'm a bit biased because we work a lot together to really make Power BI and Synapse sing. So I'm pretty excited about that stuff.
Roadmap you Power BI guys get, this is for the platform, this is where we're going for the year. And the data platform historically has been very fragmented. You kind of see this is the data factory plan, this is that plan, this is that, the lake plan. And one of the exciting things about Synapse is bringing all these products together gives you a lot more coherent view. You can talk to the Synapse team that is all these different bits and pieces. So getting a more holistic view of this is the plan, this is where we're going, that is something super exciting.
Exactly. All right. And with that, I want to thank you for your time.
Awesome. Well, thanks for having me. It's been fantastic.
Yeah, thank you. And that concludes another episode of Kasper On BI. I hope you've enjoyed it. I certainly have. I hope you liked the conversation that we were having. And if you have any comments, suggestions of things that I should cover in other episodes, please leave a comment to me. If you want to see more content, hit that subscribe button. And if you like the episode, hit the like button. And with that, I'll see you next time.